Hello, boys and girls. This is Mrs. Mouton, and I finally put together the SOL 4.5 adding and subtracting unlike fractions video. It took a while, but now we've got it. Just a little note, I'm using a different format. I'm using the QuickTime Player application, so you will be able to see everything that I do on my desktop, just like I just moved the mouse 2 minutes ago. So just so you understand that the format is a little different this time. Okay, let's start by talking about what our learning objective is. What we're going to do is, remember we've been talking about this in class, I will add and subtract unlike fractions and simplify if necessary. Keep that in mind so that when we go through the steps, you're thinking about what your learning objective is and what your goal is, so you can relate it to the steps that you're going through. What is the purpose? Okay. So let's take a look at our first two fractions that we're going to try and add together, and they are 2/4 plus 2/5. And the first thing that you should notice about these fractions right away is that the denominators are not the same. So you're going to have to do something to make those denominators the same, because we know we can't add fractions with unlike denominators. They have different parts. We couldn't express them as fourths or fifths. Let's take a look at the model so we can better understand why we can't just add them together. Here I have 2/4 on the top. 2 parts are shaded yellow out of the 4 parts it would take to make a whole, and 2/5 is the bottom fraction. 2 parts are shaded yellow out of the 5 parts it would take to make a whole. If I could take these 2 blocks here and move them up to the top, even if I could add them together, I wouldn't know how to express them. What name would I give to them? What fraction would I call them? Let's take a look. Fourths are clearly larger than fifths, so when I take these fifths and move them up, they would end up occupying less space than what I need to call them a fourth. Actually, to make it really simple, they would just be too small to fill the space in up here. So I couldn't call them fourths because they couldn't fill the space for the fourths. On the other hand, if I took the fourths and moved them down here where the fifths are, I would still have a problem, because if you notice, the fourths go past the line for the fifths. So the fourths are too big to fit in the fifth space. They would go over the line. They would be too large. Okay, so I can't express them as fourths or fifths, so I have to find a common denominator. I want to change those common denominators. And how can I do that? By turning them into equivalent fractions, or fractions that have the same denominator. And the first step in doing that is finding the least common multiple. Why the least common multiple? Well, remember our little fraction that we made, our fraction model. Remember, we never draw models because we're not a computer and we can't do models that are perfect. But just for the sake of talking about it, if we were to shade 1/2 of this very, very bad circle here, okay, and we wanted to make an equivalent fraction for 1/2, we could change our 1/2 into fourths by multiplying the number of parts. We just doubled the number of parts, okay? So what we're going to do to find two denominators that are the same is that same exact process of multiplying the number of parts that we have, okay? Which will give us a new common denominator, or new fractional parts that will be the same, okay? Thinking of, remember in class we were talking about a pizza party. The pizzas came, one pizza was cut into fifths, one pizza was cut into fourths, and you want all of your guests to have the same amount, the same portion. You don't want one set of guests to be upset because theirs is larger and then the other guests are upset because their piece is smaller. You want them to have the same parts, but they've already been cut into fourths here. They've already been cut into fifths. So now we have to multiply the number of pieces from that point. We can't start over again because they're already fourths and they're already fifths. So we have to find something that they share in common, or a common denominator. That's that down or lower number, denominator, okay? So how do we do that again? We just talked about multiplying the number of pieces, or finding the multiples of 4 and the multiples of 5 and finding one that they share in common. Remember that a multiple is that little acronym MAP. Multiple is the answer or product, which is the answer to a multiplication fact. And we're going to list the multiples here all the way to the number 10. And we do that because 10 is an easy number for us to remember. We know that 4 times 10 is 40. So if we're using repeated addition, excuse me, and we get to 4 times 10 and our answer is not 40, we will know that we've done something wrong and that we need to go back and check our answers again. So let's start. You're going to do yours slowly. I'm going to speed mine up a little bit just to save time and put all of the multiples there. Okay, so just to review what it is we're doing, multiples are the answers. Here are the answers. 4 times 1 is 4. My line is off a little bit. 4 times 2 is 8. 4 times 3 is 12. We're listing the multiples all the way again to 10, so that in case we're doing repeated addition, we can check to make sure that we've done it correctly. So we should get to 40 by the time we get down here. Once we've listed the multiples of that lower number first, because we know it's easier for us to know the multiples of that lower number, then we're going to do the multiples of the higher number. And we're going to do them one at a time, checking to make sure each time if the multiple appears in the list, because we want the least common multiple. Okay, so we would start with 5. Look down the list, 5's not there. So we would go on to write 10. Look down the list, 10's not there. Do the same for 15. Look down the list, 15's not there. And then 20. And when we look down the list, we would stop because we notice that 20 is exactly the same. Remember, we're looking for the least or the lowest number that they share in common. Both lists, multiples lists, have it. And multiples, again, we know are the MAP, the answers or the products when we multiply. So when I look at my list, I find that the least common multiple is in fact 20. It is the lowest number that is found on each of my multiples lists. Will there be other numbers that will be the same on the list of multiples for 4 and 5? Yes, there will be if we keep going. But remember, our objective is to find the least common multiple, because when we're dealing with fractions, we want to keep our numbers small. We were talking in class about how if I asked you to visualize 87 hundredths, it would be very difficult to visualize 87 hundredths of a pizza. But if I asked you to visualize 1/2 of a pizza, you should automatically get a picture of it in your mind. Smaller numbers are easier to work with. That's why we choose the least common multiple, because we want to keep our fraction as small as we possibly can because it's easier to work with. Once we found that least common multiple, remember that our whole objective is to turn these two fractions into fractions that are the same, because once the denominators are the same, all we have to do is add or subtract the numerators. So that least common multiple, 20, has now become our least common denominator, because all we've done is found out how many parts we needed to make them the same. Okay, so 20 and 20 here. Now we have to turn them into equivalent fractions. The denominator has changed, So the numerator must also change, okay? Like in our little model for 1/2. When the denominator changed to fourths, the numerator couldn't say, only going to stay 1. The numerator was then divided into 2 pieces. So the same thing happens with this fifths that has now become 20ths. The numerator also changed because when I cut that pizza or that cake up into more slices, the number with pepperoni in it also became more slices, or the number with chocolate icing on it also became more slices. It can't stay the same. So Math Ninjas, how do we find equivalent fractions? And I hope you've jumped up on your feet and hollered out, multiply, because that's exactly what we are now going to do. Multiply to find the equivalent fraction. Just like we doubled the number of pieces in 1/2 to give us 2/4, we did something to the number of pieces to give us 20 pieces. What did we do? We quadrupled them, or we multiplied them by 4. 5 times 4 equals 20. That's how we got the denominator. So now we're going to use that same process to find the numerator. In my Block 1 class, Jordan is our resident specialist, and he always says, whatever you do to the bottom, you must also do to the top. And there we go. If we multiplied the bottom times 4, we must multiply the top times 4, and 2 times 4 gives us 8. So the denominator changed to 20 pieces, which also changed the numerator to 8 pieces. Let's look at a model so we can see how that happened. If you look right here, 2/5 is on the bottom. This fraction right here is broken up into 20ths, and we're going to count the number of pieces that are equal when we change that fraction into 20ths. So 2/5 is the same thing as 1, 2, 3, 4, 5, 6, 7, 8 20ths. Okay, so our models now match. When we turn the fifths into 20ths, we need 8 of them to have the same amount. Okay, we've just taken our knife and cut our cake up into more pieces, and it's the same amount, but it's just smaller pieces. And now we need to do the same thing with the fraction 2/4. Our denominator was divided into now 20 pieces. How do we get from 4 to 20? We multiplied by 5. Whatever you do to the bottom, you must also do to the top. So 2 times 5 is 10. And let's check it again using our models. Here's 2/4, and here's our 20ths. Let's see how many 20ths are equal to 2/4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 20ths is the same amount as 2/4. Again, we've just taken our cake and split it up into more pieces. Pieces that will be the same when we look at 2/4 and 2/5. Okay, so now we take 10 20ths, and we add our 8 20ths. Our denominators are now the same, so we can just add the numerators. And 10 20ths plus 8 20ths will give us 18 20ths. So let's go back to that fraction model. Here we had our 10 20ths plus 1, 2, 3, 4, 5, 6, 7, 8 20ths. This amount here represents our 2/5, and if we count them all up, it's 18 20ths. So 10 20ths plus 8 20ths equals 18 20ths. Now, we have taken care of our first learning intention or learning objective. We have added fractions with unlike denominators by finding a common denominator, which is our 20, and then taking that common denominator, using it to find the numerator by making an equivalent fraction, and then we just added after that because both of these fractions now have the same denominator. The second part of our learning objective said that we were going to then simplify if we could, because again, 18/20ths, as we saw it in the model a few minutes ago, but had I not shown you that model, to actually visualize that in your mind is a little difficult. So we want to take that fraction down to the smallest numbers possible to represent that same fraction. And how do we do that? We do that, math ninjas, by finding the GCF. Do you remember what those numbers stand for? The greatest common factor. What we're really doing here is working backwards. We multiplied to find the number of pieces that they had in common, okay? We multiplied the number of pieces in each of the wholes. We turned 5 pieces in a whole to 20 pieces. We turned 4 pieces in a whole, again, to 20 pieces. So now we want to work this fraction backwards and see what is the biggest number that we could multiply by to get this fraction. When we find that largest number that they share in common, that we could multiply by to get that fraction, then we could use that same related multiplication fact to find the smallest numbers that could still represent this fraction. So it's like taking all those steps we just did to make the equivalent fractions and working them backwards. And when we think of factors, we should think of, again, flashcards. Remember, the greatest common factor is the last step in adding or subtracting fractions, because it's going to help you to reduce your fraction to simplest forms. And here's another thing to remember. You can only use least common multiple one time. Least common multiple makes your fraction larger. At the end, you don't want to make it larger. You want to make it smaller. Greatest common factor makes your fraction smaller. And I know it's a little tricky because the vocabulary is the exact opposite. Least common multiple makes the fraction larger. Greatest common factor makes the fraction smaller. Okay, so let's go ahead and factor our numerator and our denominator, because we're trying to take those down to the smallest numbers possible to represent this fraction. So 1 times 18 is 18. 2 times 9 is also 18. Remember, if you use your calculator, you can just divide to see if something is a multiple of 18. If I wasn't sure about 3, I can go 18 divided by 3 equals, look at that, it went in evenly, so 6, and use your related multiplication fact. So 3 times 6 equals 18. If I wasn't sure about 4, let's try it again. Sorry, trying to get to my calculator. It's being a little stubborn. 18 divided by 4 equals, it's a decimal. I know whenever I see a decimal, it cannot be a factor because factors go in evenly. So 4 doesn't work. So I go on to 5. 5 doesn't work. And then I'm back at 6 again. 6 times 3 is 18. I cross it out because remember, it's a repeat. And when I cross it out, it kind of disappears. But I want to do all my numbers just to make sure I don't miss any of them. So 9 times 2, again, is crossed out. 18 times 1 is a repeat, so we cross that one out. Then I start listing my factors. 1, and remember to put that mark up there so that you know that you've brought all your factors down. 2, mark it. 3, mark it. 6, mark it in ascending order from the smallest to the largest so that we have a system for doing it and we're not just jumping all over the place. 9, mark it, and 18, mark it. Okay, we finished 18, so we go over to 20. 1 times 20, 2 times 10. If you didn't know, again, about 3, one way to do it, if it's on the calculator part of the test, would be to do 20 divided by 3. Again, I come up with the decimal. So 3 doesn't work, but 4 does. 4 times 5 That's why it's so important for you to know your math facts, ladies and gentlemen, because there are no shortcuts for knowing those facts. They'll help you. They're related to all of the skills that we've been doing in 4th grade. 5 times 4 is a repeat, so we cross it out. 10. 10 times 2 is a repeat. By the time, and remember you're going through 6, 7, 8, 9, but by the time you get to 10, you know that 10 times 2 is 20. Any number bigger than that is automatically going to give you a number bigger than 20. 11 times 2 is 22. Too big. So we don't even have to go through all of those. We can skip right to 20 times, sorry, there's a little mistake, 1. And that also is a repeat. And I'll quickly fix that one too. Okay, we'll just leave it, sorry. So now I'll list my factors down here on the bottom. 1 and mark it, 2 and mark it, 4, 5, 10, and finally 20. Thinking of the word factor, there's an O in factor. It should help you to remember that we are going to use a Venn diagram. It looks like 2 O's together to find the greatest what? Common. Looking for what they share in common. And they share 1 in common. Mark it out. 2. 3 is only on the 18 side. 4 is only on the 20 side. 5 is only on the 20 side. 6 on the 18 side. 9 on the 18 side. Again, going from least to greatest. 10 on the 20 side. 18 on the 18 side. And 20 on the 20 side. Now we have to look in the middle because that's where we find the numbers that they share in common. Just like in language arts, we've used Venn diagrams. What they share in common comes in the middle. And the greatest number that they share in common is the number 2. Now we go back to our factors list and circle that same 2. And then we underline the digit that's next to it. We have just found our simplest form. 9 replaces 18 and 10 replaces 20. 9/10 is 18/20 in its simplest form. And remember, it's very important for you to remember how to do simplest form. I know it's a lot of steps from the beginning, adding and subtracting the fractions, to the end where you find the simplest form. But remember, 18/20 is not going to appear as an answer choice for 2/4 plus 2/5. 9/10 will appear as an answer choice. So you're going to have to memorize the steps to be able to simplify the fraction at the end, as well as all of the other steps to adding and subtracting unlike fractions. So let's go through those steps again. And I want you to copy these down in your notebook. Adding and subtracting unlike fractions. 1. Copy the problem vertically. It's probably going to be written horizontally across the page. You're going to need to copy it vertically so that it's easier to work with. Find the least common multiple of the denominators. Remember, you have to change those denominators so that they are the same. And you can do that by finding the least common multiple. We're multiplying the number of pieces that there are in the whole to come up with one that's the same for both of the fractions. This will then become your LCD, or your least common denominator, because that's the whole point, trying to get those denominators to be the same. Then you take those common denominators, math ninjas, and do what? Make equivalent fractions by multiplying. Whatever you did to the bottom, you must also do to the top. Once you've multiplied, you have now made fractions that have the same denominator. So you can just add or subtract. Remember to notice your sign. Add when it says add, subtract when it says subtract, and be very careful that you do correct computation. Check it, double check it. Then always remember to, the final step, put your answer in simplest form by finding what? The greatest common factor. Greatest common factor makes numbers smaller, or makes your numbers in your fraction smaller because you want to deal with the smallest number possible so that it's easier for you to visualize that fraction. And that only will happen if it isn't already in its simplest form. Remember, whenever you have next door neighbors, you're not even going to have to do this step. 3/4, 5/6, 11/12, 8/9. Those are already in their simplest form. You're not going to have to reduce those, but there will be others that you will have to reduce or put in the simplest form. And remember that there are several synonyms that they can use for that. Put these fractions in their simplest form. Reduce these fractions. Put these fractions in their lowest terms. I know it's a lot to keep in your mind, ladies and gentlemen, but the more you rehearse it and the more you practice it, the easier it will become, just like anything else that you're going to do. So, I hope you've enjoyed this video. I hope it's helped to make the concepts a little clearer to you. Remember to go back and watch it again, and it wouldn't be complete without leaving you with a problem to try. And you can send me the answer. Remember that the slash mark on your keyboard is what you'll use to give me a fraction on the diagonal. Usually we use fractions top to bottom in 4th grade, but in order to type it for typing purposes, you're going to have to put that diagonal between. But I want you to try 2/4 plus 1/3. Write the problem down, go back through the video, and look at the steps. And I hope you've enjoyed this. Send me a message on Edmodo.